So 7.1. We're talking about rational expressions here. Okay, what they mean by rational expressions is polynomial fractions. Okay, I'm going to write AKA polynomial fractions. That's what I'm going to call it for this chapter. They call it rational expressions. Rational means fraction, basically, in math. Because remember, a rational number is any number that can be written as a fraction. So in math, rational refers to fractions. Expression means no equal sign. So we're not dealing with any equations yet. It's just an expression. And what do we do with expressions? We just kind of reshape them a little bit, like Play-Doh. It's the same ball of Play-Doh. We don't add any new Play-Doh or anything. But we just factor it or simplify it. But there's no multiplying it by 2, because there's no equation. There's no subtracting 5. We're just kind of reshaping. Okay, so we're just taking a fraction and reducing it. So an example of this is, here's the rational expression. Okay, like 3x minus 9 over x squared minus 6x plus 9. Okay, so we got a polynomial over a polynomial. And after we simplify it, we'll talk about how in a minute. But the simplified version of this is 3 over x minus 3. I'm just going to move this out of the way. Okay, that's what we're going to be working on today. It's just a fraction that's got a polynomial on top, a polynomial on bottom, and how can we simplify it? Okay, so the first, absolutely most important thing, you can put this below, I'm going to put it next to it, okay, is remember, this is the single most important thing you can remember in this section. You can never cancel a single term. And I'm just going to go ahead and say ever from the top with a single term if you have a polynomial fraction. Okay? So for example, x squared minus 5x plus 10 over x plus 5. Okay? Let's say we got that. Okay? Absolutely never, ever, 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 ever could you cancel this x with one of the x's on top. Which x would you even cancel it with? Whatever you wanted. You could be like, I'm just going to cancel with this one or this one, just arbitrary, just slash, slash everywhere, right? And never could you cancel just this 5 that's clearly part of a group. You could never cancel this 5 with, where would you even cancel it? Would you cancel it with this 5 one time and the next time you cancel it with this 5, right? You can't just pick and choose and cancel anything you want, okay? Never. This is the single biggest thing. If you do this at the start of a problem, I will almost always give you a cataclysmic 0 on the entire problem. Because after that, it's just nonsense. I mean, you're just saying, I'm gonna get rid of all the x's. Just gone. Okay? Or the numbers are gonna completely change. Okay? Never. Instead, factor first. the big plan here. Alright, just one more example to absolutely just show you the ridiculousness of this, okay? Let's say, one more example. Right? What if we have x squared plus 2x plus 5 over, I don't know, let's say x plus 2, right? This, I see people do this. This is an actual thing I see people do. They go, oh, look, there's an x on bottom, x is on top, so these cancel with this, and so I'm left with 1 plus 2 plus 5 over 1 plus 2, and oh, look, the 1's cancel and the 2's cancel, so my answer's 5. Right? I understand that's a little extreme, but I actually see that sort of thing on tests. So never ever just start canceling magically one piece with one piece ever. This absolutely comes as a block, and this absolutely comes as a block. So just remember, never do this. Okay? This entire chapter is about how to deal with this chunk polynomial on top and this chunk polynomial on bottom. The big thing to know is you always factor. The reason you factor it is instead of 3 separate terms being added together, when you factor it, it becomes a single term, a single product. And when we have a single term, all those magical shortcuts that we love work. We can cancel anything we want on top with anything we want on bottom once it's one term and one term. As soon as it's 2 terms, life gets more complicated, okay? So I just really wanted to emphasize that. Now let's talk about how to simplify. Okay, now that we'll never ever make this mistake for the entire chapter. Okay, general strategy, it's real simple. Step 1. Factor the top completely. And factor the bottom completely. And in parentheses, I'm going to tell you the reason. The reason is the whole reason is so that when you factor it, you have one big clump of factors being multiplied together. All of our shortcuts work when we have one big term. Okay, so first step, just factor everything on top, factor everything on bottom, straightforward. Second step, cancel out any factor that is exactly the same on top and on bottom, okay? So it's a 2-step strategy. Factor everything, and if you see the exact same factor on top and the exact same factor on bottom, you cancel it, okay? So here's a good example of what I mean, okay? Here's number 32. So we have 5x minus 10 over x minus 2. Alright, since this x on bottom is already to the 1 power, this one is, you could think of it as already being factored because it's a prime factor, because it's x to the 1. You can't split up an x to the 1 anymore, and there's no GCF, okay? However, we could factor the top a little bit. What could we do at the top?
GCF.
Yeah, what's the GCF?
2. No, 5.
5. You're left over with the 2. Yeah, so we got 5 times x minus 2 over x minus 2. And then
We just select the x minus 2 on top with the x minus 2 on the bottom.
exactly, we have a whole x minus 2 with an entire x minus 2. And so this is equal to 5 over 1 or 5. Awesome. Okay, this is similar to, okay, imagine I have this problem. So just similar to, let's do, I think I wrote a good one in here, yeah. Okay, similar to 20 plus 12 over 60 plus 12, okay? Could I cancel the 20 and the 60?
You can simplify.
How? What? No!
Reduce it.
Right?
It's 1/3, right?
Uh-uh. Yeah.
Combine like terms and then.
Yeah, you have to add them. You can't cancel ever, 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 ever. Can't. Cancel. Right? Never. Because of this equal sign. Or I mean, plus sign. Right? It's 2 terms on top. So first you would say, this is 32 over 72, and then now I have 1 term on top and 1 term on bottom. So what I could do is essentially write out the factors and say this is 2 times 2 times 2 times 2 times 2. And on bottom it's 2 times 2 times 2 times 3 times 3. And so if I were to split it up into its factors, I could exactly cancel out every factor that shows up on top that also shows up on bottom. Well look, 1, 2, 3, 2 shows up on top and bottom, and that's equal to 4 9ths. So the exact same way I deal with numbers is what I'm doing now. The reason it's a little more abstract, the reason it's more challenging, is we're saying, what if instead of a number, it was an x? But follow all the same rules, all the same process, and simplify. Okay? We combined everything we could, and then we factored it into its factors, and said, oh look, the exact same factors show up on top and bottom, cancel them. And what are you left over with? Okay, same thing up here. Alright, so, you guys fell for the trap. After all my never ever talk. Alright, that's okay. Everybody can make that mistake once, right? And then we learn from our mistakes and we grow and we emerge from our chrysalis as a butterfly.
Nice.
It's amazing. Okay. I'm purposely leaving something out, and we'll come back to it, but let's just do a couple more examples. And I'll tell you the one thing we're leaving out, we're not going to do it in this class, but it's important, so I'll at least mention it. Okay. So here are some problems, like 21, 22 is what I meant. 9x squared over 6x. 24 is 7x plus 21 over 49. We just did 32, and then let's go with 34. Okay. So these are some good solid examples, starting from the easy where it's already 1 term over 1 term, to then going 2 terms on top, to then 2 terms on top and 2 on bottom. Okay, so how will we simplify the first one?
Cancel the x's?
Yeah, because they're already 1 term, so we can use all our cool shortcuts. How many x's are left over?
1.
Yeah, 1, okay. So we're left with, on top is 1x, on bottom is just 1, no x's. Okay, what about the numbers?
We simplify it to be 3 over 2.
Yeah, we divide it by 3, divided by 3, then we get just 3 over 2. So our answer, 2 times 1, is 3x over 2. Awesome, okay. 24.
So just as long as we're not separated by like a plus or a minus sign, they're considered one whole, no, we considered two separate.
It's as soon as there's a plus or minus sign, it's separated into two terms. As long as it's multiplication and division, it's all one big clump, glued together by multiplication and division, and that's when all of our wonderful rules apply. So about 24, what would we do? Kathleen, what would we do on 24?
You find the GCF.
Exactly.
So
First
7.
big step is factor. So yeah, GCF, as you said, 7.
Yep.
So what do we get?
3x, 3x, yeah.
Do it first, so what's the first
Oh,
term?
7x,
So you take out the 7 and you get
so x,
yeah,
and then plus, that's 3.
exactly. So you're left over with the x plus 3 all over 49. And now that it's all factored, look at it, it's one clump, 7 times something over 49, we could simplify, so?
So, the 7x plus 3,
Oh.
or, 1,
We don't go
or
backwards.
1,
Yeah,
1, and then 7,
exactly,
And
just
then-
reduce those numbers.
yeah,
So we're left with 1x plus 3 or x plus 3
over
Over.
7.
7. That's it. Again, the big step is factor, then cancel out anything you see on top and bottom. Okay, what about 34?
Factor out the x squared minus 16 to x minus 4, and then the x plus 4.
Yeah, x minus 4 and x plus 4, yeah? So now I've got x plus 4 over x minus 4, x plus 4, and then
Cancel.
cancel what?
X plus 4.
X plus 4 and
X plus 4.
what are you left with?
X minus 4. 1 over.
Ah, you both caught yourself, nice. So, common mistake is just saying I'm left over with x minus 4. That's true that you are left over with x minus 4, but you're left over with it on bottom. So this is 1 on top, so it's 1 over x minus 4. Perfect. Okay? Just to throw a teeny curveball at you real quick. What if we had can't remember what number it is, 58.
Be 1 over x minus 5.
You can't simplify,
Ah, why?
because the bottom can't be factored.
Exactly.
Why not?
Can't be simplified.
Why?
Yeah, why?
Is it addition?
Exactly.
Squares, difference of squares with addition?
Exactly. Because of the addition sign. It has to be a squared minus b squared.
Is the school got a test?
Yeah, of course.
Yeah.
So, the reason it has to be x squared minus 25 is because when you have x plus 25, x plus 5, x minus 5, the whole reason this works out to be 2 terms and not 3 is because the plus 5x and the minus 5x have opposite signs. So plus 5x minus 5x, the middle terms exactly cancel out. That only happens when the two signs are different. So positive 5 times negative 5 has to be a negative, right? It can't be a positive. So that's a big one, yeah. So that can't be simplified. Perfect.
So what do you call it, or you just say it would be by, what do you?
You can't say it can't be simplified. Yeah, nothing special about it. It's like if I said simplify 3/4. You just be like, yeah, it's already simplified. Yeah. Okay. So I'm gonna mention one thing that we're not doing in this class, but it's important. And then what I'm gonna do is show you one really common trick that you already know, but I just wanna highlight it. And then I'll just do some more examples with you, but important. we're purposely leaving something out. For example, you already did this example, 5x minus 10 over x minus 2. So that was 5 times x minus 2 over x minus 2, which cancels and gets 5 over 1, or 5. Okay, this is true, except, when is this not true? Looking at the original problem and thinking about golden rule of mathematics.
When x equals 0.
Yeah, if the bottom is equal to 0, except when x minus 2 equals 0, or x equals 2, okay? The original fraction isn't defined, okay? This is a concept. Whoops. You will look at in more depth later on. Okay, but I just want you to be aware of that. When you simplify a fraction and you cancel these out, that is true for every single value out there except for one, and that's an important exception. So in math, what you would properly write is you would say, this equals this, or you wouldn't even write words, you would just say, and x cannot be 2, so this would be your final answer. For us, since we're not going deeper, we don't need this, and it just becomes a nuisance, and it's kind of, I feel like it confuses people more than it helps right now. However, later on, when we would take our simplified fraction and solve an equation with it, this becomes really important. Okay, so in this class we're not going to do it, but I just want to show you that that's there. When you simplify a fraction, things that canceled out are still kind of fossilized in the problem somewhere, saying, and we couldn't divide by 0 in the original. That's it, just want to mention that. Again, we're not going to do that in this class, but it's good to see. Okay, so you do have one really common trick, but let's do another example first. Okay, or two examples first. Here's 38. Okay, x plus 2 over x squared minus x minus 6. And then one more, I'll do it right here. 42. Y squared plus 5y plus 4 all over y squared minus 4y minus 5. Okay, so what do I do first?
On which one?
Both.
On both? Got to factor it out?
Yeah, always factor first, just reminding you. Okay, so let's start with the 38 because it's easier. So, top,
Stays.
yeah, already factored, check. No GCF, it's already x to the 1 power, done. Bottom one,
Be x, or yeah, x right.
yeah,
Be negative 1,
yeah,
negative 6,
okay,
which will be 2, negative 2 and positive 3. No, negative 3 and positive 2.
there we go. Found our two numbers. So this becomes x plus 2 over, and again, the factoring part should start becoming second nature. You should be thinking overall strategy, okay, I need to factor first, and then hopefully the factoring is, okay, I can get to here, and
X
then,
plus 2 cancels each other out.
Exactly.
Be 1 over x minus
exactly, perfect. Okay, same thing over here, right? So we start by factoring the top, sum is 5, the bottom is 4, so we get 1 and 4. The bottom one, sum is negative 5, negative 4, negative 4, negative 5. So we get negative 5, positive 1. So hopefully that factoring is getting easier, and I see y plus 1, y plus 4, all over y minus 5, y plus 1. Once you factor it, it's so much easier to see. So all you need to really know is factor it first. So then what do I do?
Cancel the minus one.
The entire y plus 1 from top cancels the entire y plus 1 from the bottom. And yep, y plus 4 over y minus 5. Okay, just going to give you a common trick and something to be careful about. But that's really it. Okay, factor everything on top, factor everything on bottom, and entire things cancel. Not just the y from one part. Okay. So here's the very common trick. Okay, you already know this. You do. And I'll write actually what the common trick is up here, just in case it helps. A minus b is equal to negative b minus a. This only works with subtraction, okay? But a negative sign flips it around, and that's something we'll use pretty often. But the way I like to think about it is if a binomial is written in the wrong order, if you have two terms and the number is first and the x is second, rewrite them in the correct order. Okay, so quick example, what I'm talking about here is if I give you 7 minus x, okay? That looks like it's already factored, it looks like it's prime, however, because it's written in the wrong order, first thing we would say, well, let's just write that in the right order, negative x plus 7. And then say, well, wait a second. If there's ever a negative in front of my lead coefficient, I'm gonna pull out a negative 1. So I'm going to say the GCF of this little thing here is negative 1, and I'm going to say, okay, this is negative 1 times x minus 7. And that's that relationship that I wrote up here. If you have a minus b, if you factor out a negative, it flips. Okay? And that's going to come up relatively often. Show you an example or two of this. Okay, here's number 60. Number 60 is x minus 7 over 7 minus x. Okay, as is, looking at it, they look similar, okay, but they're not exactly the same, so we can't cancel. Okay, so first we would have to rewrite this bottom. We'd say, okay, well that's x minus 7 over negative x plus 7. And then we'd say the GCF of this bottom one is negative 1. And we would say this is the same as this. Okay, and that's where that trick comes in. They are actually the same with a negative sign added in there. So now this entire thing cancels with this, and we're left with 1 over negative 1. Or negative 1. Okay, but anytime I show you a trick like that, we gotta be careful we don't over apply it. So be careful. factors have to be exactly the same. If it's x plus 3 and x minus 3, those absolutely are different things, but they absolutely don't cancel. Okay, a similar situation. Right? 17 and 27, hey, they both have a 7, right? Looks similar. But they don't cancel. Okay, just to show you an example like that, okay, the book gives you, oh, well, I thought they did. Maybe I don't have it written down. The problem I was thinking about, oh, yeah, 64. So 64 is x minus 7 over x plus 7, okay? How would you simplify that?
So you take out the -1, the GCF of the x minus 7.
But the first term is positive. And if you did take out a negative, this would be negative 7 minus x. That doesn't help, let's go backwards. So 64. Just like up to that star above it.
Cannot be simplified.
Yeah, can't be simplified. These are totally different things. Cannot be simplified. And that's important. Okay? Let's do 2 last examples together. Okay, here's 70. X squared minus 4 over 2 minus x. We're applying exactly what we just learned. And then one last problem. This will just involve the hokey pokey. It's got multiple variables. So it's just kind of a little bit of everything factoring. One of the harder problems in the section. Just because the factoring is a little more difficult. Okay. So on the first one, what would we do?
Change the bottom.
Well, yeah, so we can work on the bottom first. How would we change the bottom?
Would be -1 times x minus 2.
Exactly. So at first we'd say negative x plus 2, then taking out that -1, we'd be left with x minus 2. Okay, so on bottom we got -1 times x minus 2. Okay, what about on top?
Factor out the x2 and the -4 to make x minus 2 and then x plus 2.
Exactly. Difference of squares, x plus 2 over x minus 2. And now because these factors are exactly the same, after pulling that negative out, they're exactly the same, we cancel them. So that one common trick is really the only trick you see in this section. Otherwise, it's straight, factor everything on top and bottom, cancel anything that's exactly the same. Okay, and so we're left with, you could leave it as x plus 2 over -1, though that's a little sloppy. If we're dividing by a number, we could just split it up. Okay. So we get negative x minus 2. Alright, so this one is the last one, kind of culminating problem. Alright. So on top, GCF, there isn't one. 3 terms. Hey, the variables go x's down, y's go up. So we're going to use our normal x factor here. Sum is positive 3, product is negative 10. But what's our result going to look like?
X plus something y
Exactly.
times x plus something y.
Exactly. That's all the 2 variable thing means. So the first part of our binomial will have an x. The second part will have a y. Okay, still factor it the same way. So, multiplies to be -10, adds to be that, we get positive 5 and negative 2. Okay, so x plus 5y and x minus 2y, that's the top. Okay, on the bottom, same thing, except now we got a 3 out front, so we got to do what?
Hokey pokey.
Yeah, gotta do that hokey pokey. Put the lead coefficient in, and she'll get all about. Okay, so we get a positive 6y squared. Now we get the same thing over here, which is negative 7 and positive 6. What's our general form here gonna be?
X squared? No, X something. X plus something. No, 3x.
Yeah, because we
Plus-
multiplied it an extra 3, so we're gonna have 3x.
X plus something y
Exactly,
times 3x plus something y.
exactly. Okay, that's gonna be our general form of this factor bottom. I'll do it over here off to the side, so this ends up being my final result. So I got 3x plus some number of y's. Over here I got negative 1 and negative 6. Okay, and I gotta divide that all by 3 to get my 3 out. Okay? My GCF here is 1, my GCF here is 3. So I got 3x minus 1 times, 3 times x minus 2 all over 3. And going down here, oh sorry, there's a y in each of these. I get 3x minus y and x minus 2y. So again, in terms of new material here, there is almost nothing new. The only difference is the factoring is a little more challenging. In terms of strategy, all it was factor top, factor bottom. That was the whole strategy that was new. And then we're gonna cancel anything that exactly shows up on top and bottom. Do you see the exact same thing on top and bottom?
X minus 2y.
Yeah, x minus 2y and x minus 2y. So our answer is x plus 5y over 3x minus y. So if you're having anxiety over this problem, like, oh man, that's hard, that's all chapter 6, okay? The only new part was factor and cancel anything that's exactly in top and exactly in the bottom. But all of that factoring is chapter 6, and that's what I'm saying. If you don't have this factoring down right now, that's what you need to focus on, okay? Go to the MLC, get help.